Hello, this is Dr. James Camp from Lee College in Baytown, Texas, and this is the Integument, Gross Anatomy and Physiology, part 1 of our section on our unit on the integumentary system. Today we're going to list the components of the integumentary system. We're going to describe the general functions of the integumentary system and the subcutaneous layer. We're going to compare and contrast thin and thick skin with respect to where it's found in the body. And we're going to describe the gross anatomy of the skin by body region. Okay, so when I start this, I like to ask, what has your integument ever done for you? Because our skin is one of the most little understood organs in our body as far as how much it contributes to our health and well-being. First off, there are 5 sub-organs to this integument, and I encourage you to take a moment here, hit pause on the video, and see if you can list out all these 5 different parts of the skin, and see if you can figure out for yourself what the parts are. While you're doing that, you can also look over on the right side of this slide and say that there are 5 main functions of the integumentary system. You can see if you can list out what those are. So hit pause, take a few minutes, see if you can list these out, and then we'll come back. All right, so what are the sub-organs of the skin? The first and most obvious is what we call the cutaneous membrane, or the skin. Okay. The cutaneous membrane is a epithelial membrane. Hopefully before you watched this video, you watched our introduction to epithelial tissues, and you understand that there are 4 types of epithelial membranes, and that the cutaneous membrane is one of those 4 types. But like all epithelial membranes, it's got a connective tissue layer, the dermis, and a epithelial layer, the epidermis. There is, in addition to the cutaneous membrane, there is hair. Okay, this counts in my mind as sort of a sub-organ of the skin. We have parts of our body that have a tremendous amount of hair on them, mostly the scalp for most of us. Then going with that, you can imagine the next one is probably going to be nails. Okay. Humans have nails more as a vestigial structure coming from our mammalian ancestors than for any particular functional purpose, though they tend to help significantly when trying to take apart your children's Legos or certain other things. We often use them to pry things apart, peel an orange, that sort of thing. But they're not as essential to our survival as, for example, the claws of a cat or a dog that are necessary for grasping and tearing apart prey or something like that. We have glands. There are 2 kinds of glands in the body. One is sebaceous, and the other is sudoriferous. Okay. Sebum is oil. Okay. And the sebaceous glands are the ones that maintain the oily coating on the surface of our skin that protects our skin from drying out, has mild antibiotic properties as well, so is a general protectant. Sudoriferous are the sweat glands. For sudor means sweat in Spanish, I believe, as well as in Latin. So if you're a Spanish speaker, you have a leg up on the rest of us here. There are several kinds of sweat glands. We'll get to those in a future lecture on the components of the skin. Okay, and then finally we have touch sensors. Okay, there are a number of different kinds. Some are bare nerve endings with simple touch-sensitive cells that they connect to. Others are encapsulated in these structures called corpuscles. And again, we'll get to those in a future lecture as well. All right, so let's switch over then to the 5 main functions of the skin. The main reason we have a cutaneous membrane is to protect our body, to seal the outside out and the inside in. And so there are a number of ways that we're protected. We're protected from infection because our skin, our cutaneous membrane, forms a complete solid barrier to prevent germs that are floating around in the air from getting into our deeper body. We may have cases where the skin itself gets infected, and in fact, your skin, even when healthy, is covered with a plethora of microorganisms at any given time, some of which are healthy and sort of symbiotic, help us deal with the stuff in the big bad world out there, others of which are just along for a free ride. In addition to infection, our skin protects us from dehydration. At some point in our evolutionary history, if you push the time scale way back to before the dinosaurs, all living beings had to stay close to water. That if you were a fish, if you were a frog, you had to stay close to water, otherwise your skin would dry out and dehydrate, your body would dehydrate completely. So in order for our ancestors who someday became reptiles, birds, and mammals to be able to live completely away from water, they had to develop a keratinized cutaneous membrane, something that would lock in moisture and lock out the dry air. It also works the other way around, by the way. We can go swimming in chlorinated water in a swimming pool and not have to worry about that chlorine disinfectant from getting into our body and damaging our cells. So the keratinized membrane works very well both directions in keeping the water we want in and the water we don't want out. Fish, though they have scales to protect them, do not have that kind of completely water-resistant membrane, which is one of the reasons why you can't put saltwater fish in fresh water or vice versa, is that the effects of the water through their skin would damage them. Okay, other things that the skin protects us from: abrasion. Okay, imagine, well, remember, there's probably some time in your life when you have fallen on a rough surface and skinned a knee or gotten an abrasive injury to your arm or your elbow or something like that. Imagine if your skin hadn't been there and instead you had torn the muscles, ligaments, tendons of the deeper tissue. So your skin is built to take one for the team and absorb abrasive impacts. And then finally, we have one more thing that the skin protects us from, and that is UV light. Okay, the pigment in your skin, whether you're a sort of pale white person like me, or whether you're a person whose ancestry goes back to Africa or something, and you have very dark skin, you have some pigments in your skin that are designed to absorb UV light. If you try to make yourself tan every summer, what you are doing is building up those pigments, those melanin pigments that absorb UV light. Mild amounts of tanning can be healthy for you, can protect you from UV light, but tanning too much or too quickly means you're actually exposing your skin to UV light in the process and can lead to skin cancer. All right. Why do we need to be protected against UV light? Well, my little hint about skin cancer there gives us the answer. UV light damages DNA. And as you remember from the cell cytology chapter of this class, DNA is essential to make sure that you have the right proteins in your cell, and proteins do all of the things that a cell does. Well, one of the things proteins do is regulate cell division, cell multiplication. If you damage the DNA that controls cell division, instead of the cell dying because of its damaged DNA, it will actually do the opposite. It will grow exponentially, and you have a tumor. And if that tumor breaks out of a contained location and starts to spread, then we call it a malignant tumor or a cancer, and that is where UV light can be incredibly dangerous. All right, so let's look at some other things that the skin does for us. Thermal regulation. As our major interface with the outside world, it makes sense that the skin would be the thing that controls whether we lose heat to our environment or not. And it should be obvious some of the ways in which this works. Sweat, for example, obviously exists to evaporate from our skin and carry away heat. But also, dermal blood vessels can act kind of like your car's radiator and carry heat to the surface of your skin, where it can radiate away from your body, be carried away by the wind, that sort of thing. Or they can redirect the blood in your skin to a deeper level where you conserve heat and do not cast your heat away on a cold day. If we were furry creatures, which most humans are not, I don't know of any humans that I've ever met who have enough hair on their body to actually thermoregulate, though some of us have more hair than others. But even if you're a very hairy-legged, hairy-armed human, you probably don't have enough hair to form an insulating blanket around your body, like a dog or a cat or any number of other mammals. Almost all other mammals have a layer of fur covering their body that, if the mammal makes that hair stand up, it forms a nice insulating blanket around their body that retains heat. And then if the fur lies down, it allows more heat to transfer through the skin. Okay. Some other things. Synthesis, particularly of vitamin. Yeah, that's good, James. Vitamin D. We'll talk about that in our day on integumentary physiology, but essentially your body can make precursors of vitamin D that can be activated by sunlight to produce vitamin D. So while UV light is dangerous to us in certain amounts, it is necessary to us in other amounts. UV light can damage our DNA if we get too much of it, but if we don't get enough of it, we can't synthesize the vitamin D that we need. This leads to some people experiencing something called SAD, seasonal affective disorder, appropriately shortened to SAD. That not enough vitamin D means you're not bringing in enough calcium, which means your nervous system is depressed. And so those people feel a seasonal depression when they live in a place where it gets dark in the winter and they no longer get enough sunlight to make enough vitamin D. They sell bright lights that you can mount next to your desk so that if you're working an indoor job in, say, upstate New York where it gets very dark during the winter, you can shine this light on yourself while you're working and make up some of that vitamin D you're losing by not being outside during those hours. This is also one of those, I'm talking about evolution a lot more than I usually do today, but the skin is just a great place to talk about that. One of the reasons we believe that humans have different skin colors is that people whose ancestors come from places close to the Arctic Circle, the Northern Europe, for example, often lived large parts of the year without enough light to produce vitamin D. And so their skin evolved to have very much less melanin, to have that pale peach color that we recognize as so-called white skin, so that more light would get through so that they could make more vitamin D. Whereas people whose ancestors come from places near the equator, Africans or Mayan Indians or things like that, their skin evolved to have more melanin to protect them from the constant barrage of UV light, which doesn't really even take a break during the winter in equatorial regions. And so they evolved more melanin and darker skin. Nowadays, we move around the world, and you can't count on somebody having the right skin type for the place where they live. So we have people like me who are from mostly Northern European descent who have very light skin and sunburn pretty much every summer. And we have other people who have ancestors from equatorial Africa or equatorial South America, whose dark skin is not very well adapted to them living in, say, Detroit or upstate New York or something like that. And so they have to take lots of vitamin D supplements or do something like that to deal with the fact that there's not enough light. Okay, moving on. Some other things that our skin does for us. Excretion of wastes. Okay, you may not think of your skin as a major excretory organ, but every time you sweat, small amounts of whatever's in your blood get into the sweat. And so the same kind of wastes that come out in your urine in a much more selective way also come out in the sweat. And if you're ever, say jogging and sweat drips from your brow into your mouth and you taste it, sometimes it tastes salty, and that's, a nice, normal, healthy thing for sweat to taste like, but sometimes it tastes a little bit bitter, and that's because you've been excreting wastes into your sweat along with the salt water that's usually there. And then finally, matching up with the touch sensors, our skin is a major sense organ. In general, the senses it provides are touch, pressure, and temperature. Okay, so if you're feeling cold when you walk outside this morning, it's because the temperature sensors in your skin are interacting with the air outside your body. If you're feeling hot when you walk outside this morning, the opposite is happening. The temperature sensors in your skin are being warmed up by the air outside your body. Integumentary functions, we just covered this, but I'm going to sum it up again, include protection against fluid loss, pathogens, toxins, UV light damage, thermoregulation by sweating, vasodilation, and hair erection, sensation of the types that include light touch sensors, pressure sensors, and temperature or pain sensors. If you're not sure quite what the difference is between light touch and pressure, imagine somebody touching your skin with a feather. That's obviously kind of a light touch, right? You notice when it's there, you notice when it's gone. As long as they're moving it back and forth along your hand, you're feeling it, okay? Or imagine picking up a pencil, and as long as that pencil is in your fingertips, is being held by your fingertips, you feel the pencil there. But you feel it in kind of a light way. You feel it in a way that you're aware of its texture, and if it's one of those typical pencils that's cut in a hexagon, you can notice where the sharp parts and the flat parts are on each side of the pencil. Pressure sensors are deeper in our skin, and they sense what we might call deep touch. So if you are sitting if you've ever sat in a wooden chair for a while and you get to this point where it's sore, it's pushing into your butt, that is pressure. Or if you put on a pair of jeans that's too tight and you feel them squeezing in on your skin all the way around your legs, that's pressure. Pressure sensors are not always on. They sense changes in pressure. So when you put on those tight jeans, they are uncomfortable at first, but you get used to them. You accommodate to that feeling. But then later in the day, when you take those jeans off, you have this feeling of release of pressure, this kind of feeling. And that's how pressure sensors work. And of course, temperature, as I mentioned before, and your skin is also your major pain sensor in the body. Almost every organ that you have has pain sensors, but your skin, because it's exposed to the most number of insults and injuries in the world around us, is probably our most common sense of pain. Then there's synthesis of vitamin D and excretion of salts and waste products. All right. Now I want to transition to talking about the gross anatomy of the skin. Most body systems in A&P, I like to talk about the gross anatomy first before we dive into the microanatomy to give you an orientation to what's there. However, there's not a lot of gross anatomy to talk about in skin because it's one organ that covers the entire body. However, there are some differences from place to place, and I want to talk about those real quickly. The first thing I want to talk about are cleavage lines. These lines of cleavage indicate the direction that the skin is being pulled or stretched by the direction of the elastic fibers in the skin itself, the direction of the muscles underneath it. Each part of your skin is stretched in a preferential direction. And surgeons have over time mapped out these lines of cleavage so that they know when you're doing surgery in a particular part of the body, which way you maybe want to cut. If you look at the top box here, this particular wound was cut perpendicular to the lines of cleavage, and so those cleavage lines are acting to pull the wound apart. Okay, and so it's going to take a lot of stitches to close that wound. If you imagine stitches as being purple here, you're going to have to do something like this to pull that wound together, and even if you do a really good job with your stitches, there's a good chance it's going to leave a scar. If you look on the other hand at the bottom wound here, this wound was made parallel to the cleavage lines, and so the cleavage lines are actually pulling on the narrow edges of that cut and acting to draw the edges of the cut together. Okay, so this one you may be able to get away with a lot fewer stitches, maybe like that, or perhaps you could even use some of that surgical tape that they have that holds a wound together and doesn't require stitches to come in later, doesn't require to go in later and then pull out stitches. Or you could use biodegradable stitches that naturally dissolve over time, or all sorts of things. Much more versatile treatment for this wound that was cut parallel to cleavage lines. So if you look at the person standing sort of in the center of this slide here, if we needed to cut open a part of their body to get to, say, do an appendectomy, we'd want to cut this way, parallel to the lines of cleavage, so that that wound would naturally close, and we wouldn't have as much of a chance of a scar forming afterwards. We would, though, have to actively pry that wound open while we were sticking in our little microsurgical instrument to do the surgery. Okay, so that's cleavage lines. The next one I want to talk about is rule of nines. Moving from the operating room to the emergency room, from OR to ER, if a person comes into the ER, most with damage to their skin, most ERs have a rule that if you have about 25% or more, damage to 25% of the skin or more, okay, by skin area, that person has to go to a critical care unit for burn treatment, where they can bandage the skin properly and keep the patient from dehydrating while all of the other treatments that they need go on. Because again, the skin plays a major role in keeping you from dehydrating, also protecting against infection, and all those protections we talked about on the previous couple of slides go away if you lose 25% of your skin. But the question then becomes, how are we going to figure out if 25% of the skin is damaged? Do we pull out a measuring tape and start trying to estimate the size of each burn and then calculate the size of the whole patient? Well, that would be difficult and would take too much time in an emergency situation. So instead, some enterprising fellow calculated that you can divide the body into areas that each carry about 9% of the skin. So the whole head, front and back, is 9%. Each arm, front and back, is 9%. The body divides into kind of 9 up here and 9 down here, and then on the back another 9 up here and 9 down here. Okay, lots of skin there. And then the legs also divide into sort of 9 on the front and 9 on the back, or 9 on the top and 9 on the bottom, or however you want to divide that. 18 for the total leg. So if a patient came in with burns, you know, they maybe got in a car accident and there was a gas tank explosion and they had burns like this, we would say, okay, total loss of the arm there, 9, maybe 4.5 here, you know, half of a 9 there, 4.5 here. So that adds up to 9. 9 plus 9 is 18. So we haven't hit 25 yet. Okay. If this went on down here, though, we'd have, that would be a whole 9 now, because the whole front is 18. So 9 plus 9 is 18, plus 4 is 22.5. So now we're really close to that level. And if there were any more burn, you know, down here, then, you know, then we hit that 25 and we need to go to the critical care unit. Interestingly enough, children have much bigger heads than the rest of their body, and their legs have not grown as much. So you reapportion this as 2 9s for the head, and then about 9.5, 9 and another half of a 9, 14.5 for each leg. And finally, if you multiply all of these 9s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 9 is 99, so that leaves 1% of skin. So whatever wise guy came up with this decided that the 1% around your genitals, or the circle around your genitals, was 1%. I guess unless you're a really, you know, well-endowed guy, then maybe it's 2%. I don't know. Okay. So rule of 9s. Finally, the skin is not the same all over your body. You probably know, just from thinking about your own body, what some of these differences are. So there is thick skin in some places and thin skin in other places. Some skin is more sensitive than others, etc. Again, I encourage you to pause this video for a second and see if you can list out what you think to be the one or two skin areas that fit each of these categories. All right, so the thickest skin, there is actually a type of skin called thick skin, which is a different histology than the skin on the rest of the body, which is known as thin skin by comparison. Thin skin has hair follicles. Thick skin does not. Thick skin has an extra layer to its epidermis, a stratum lucidum, and it has a very much thicker keratinized layer. So this thick skin is found in the palms of hands and soles of feet, or if we want to use our technical terms, plantar and palmar skin. Okay. Because these have no hair follicles, plantar and palmar skin also has the least hair of any part of the body. That also includes the skin on the undersides of your, or the palmar sides of your fingers and the plantar sides of your toes. Okay, you'll notice that you don't have any hair on those parts of your fingers and toes, but if you look at the back side of your fingers, you might see little hairs popping up there. Often very small hairs, maybe even too small to see without a magnifying glass, but they are there. The most hair on your body, I think we could all agree, that is the cranial or scalp skin, right? That for most people, unless you're one of those men who has that attractive bald look, you have most of your hair, or you have the most concentration of hair on your cranial skin. I'm in my 40s, so I have less hair on my cranial skin all the time, but I still have more hair there than anywhere else in my body. Runners up would be axillary, pubic. The axillary and pubic areas grow thick spurts of hair during puberty. And for males, if you don't know that, the little circle with an arrow going up is the male symbol. Many of us grow an accumulation of facial hair during puberty and from then on in our life. Okay, most sensitive. I get in a little bit of a fight with my students sometimes over this category because many of them want to say, the genital skin is most sensitive or the facial skin is most sensitive. Those are in the runner-up category. They do have a lot of nerve endings, and their nerve endings are programmed for the brain to pay a lot of attention to them. But just from a purely scientific, where you have the most nerve endings in your body, it's fingertips. Okay, you have the ability to close your eyes and feel your way around the world with your fingertips because there are so many nerve endings there. You can pick up an apple and an orange and tell the difference from the texture. You can orient a pencil in your hand based on how your fingertips are feeling it, that sort of thing. Couldn't quite do that with your facial or genital skin. Not that I could conceive of any way that you would try to feel your way around the world using your genital skin, but I don't think you could. But you can with your fingertips, and that's an important, highly sensitive area. Your toe tips actually also have very high sensitivity because those are used for balance. If there's too much pressure on your toes, you're going to naturally lean backward a little bit. If there's not enough pressure on your toes, you'll lean forward a little bit. Okay, the most elastic skin in the body. Again, I get in little fights with my students over this because often they want to say that it's the abdominal skin because every time you eat a big meal, your stomach stretches a little bit, but really that doesn't have that much effect on the skin. And if you notice that when women get pregnant and their skin really stretches there, they often get stretch marks, which is an indication that the skin is not as elastic as perhaps it could be. The most elastic skin is actually the skin of your body that you distort and stretch multiple times every day, maybe even multiple times every hour, and that is your facial skin. You have to distort your facial skin to open up wide to eat a hamburger or to smile at someone or frown at someone else. Any of those things can cause major stretching, realignment of the skin, and it's the elastic fibers that are there that keep us from wrinkling our skin every time we do one of these activities. Those elastic fibers do wear out over your life, and so by the time you're my age, you start getting little, what we call laugh lines or such in your skin that show where you have used those smiling and eating and other such stretching things. Okay, and then finally we have the types of sweat glands. There are certain sweat glands that show up at puberty that give us our distinctive body odor. Those are found in axillary, pubic, and a few other parts of your skin, mostly in the axillary and pubic regions. Maybe some in your groin, maybe some in, for women around their nipples a little bit. But these special sweat glands give each person a unique odor. And while at first, as these things are developing in puberty, that body odor is very, very unpleasant, and you really notice it if a, say a 7th grader or 8th grader hasn't showered in a couple of days. They really develop a smell. Over time, that smell kind of ripens into something that actually is attractive to the right kind of person. And act sort of as human pheromones. Pheromones are molecules that some animals give off to attract mates, to warn other animals of what emotional state they're in, to do all sorts of olfactory signaling between different cats or different dogs or whatever. But humans do not produce exactly pheromones like that, but we do produce these smelly sweat compounds that they've even done little studies where they have men, post-pubescent men, college-age men, sleep in the same t-shirt for a week so that it accumulates their smell compounds, and then have women of the same age sniff those t-shirts and rank the guys by who has the sexiest smell. And that may sound like the most disgusting thing ever, but it turns out that when they then have kind of a meet and greet and you rank the guys on first impression, the guys who the woman liked the smell of his t-shirt tends to be the person that they have the strongest, best first impression of, regardless of how they look, regardless of what they end up talking about, whatever. That smell connection makes a serious impact. So you can, if you are coupled up, you can thank your axillary sweat glands for possibly attracting your mate. If you're not coupled up, you can try to work those out a little bit more. There are actually some kind of hipster communities, I guess you could call them, who have started holding pheromone parties where people come with a t-shirt that they've already gotten a little bit smelly, and they pass the t-shirt around the room and let people decide who they want to hang out with based on the smell of their t-shirts. Sounds ridiculous at first, but these people swear that this is a good way to meet the love of your life when all other options have failed. Okay, cerumen is a waxy substance. You know it as earwax. Okay, so the cerumen glands are found in your otic regions. Your ear canals are the only internal space in your body that is not lined by a mucous membrane, and so they secrete this waxy, oily sweat that protects them in much the same way that mucus protects all of your other internal areas. And then finally, maternal glands. This should be fairly obvious that we're talking about mammary glands here. And those are obviously found in the breasts. Interesting fact about those, the mammary glands do not actually develop into glands until a woman is pregnant her first time. Prior to that, if the woman has large breasts, it's purely fat. It's a lot of adipose tissue and a little bit of preglandular tissue just behind the nipple, but there's no gland there to produce milk until the woman has gone through all of the hormonal changes of her first pregnancy. Okay, so I've dwelt on the gross anatomy of the skin here for long enough. We're going to wrap this up now, and the next couple of videos will take you through the layers of the skin and the various structures of the skin, and then we'll wrap up with a video on the physiology of the integument. So, okay, hope you learned a lot. Happy studying, and we'll see you in the next video.